Alright, so today's lesson we're going to look at division of polynomials specifically. In the very first lesson, we're actually going to focus on all four operations of polynomials, so addition, subtraction, multiplication, and division. But the main focus is really division, with the other operations should really have been covered in previous cases. The specific AICE objectives for this unit say you must be able to divide a polynomial of degree not exceeding 4 by a, I'm supposed to say linear or quadratic polynomials, and identify the quotient and remainder, which may be 0, and also use the factor theorem and the remainder theorem to find factors, solve polynomial equations, or evaluate unknown coefficients. So the AICE objectives go into a lot more specifics about what you exactly need to do. And that's probably the one that's the most important thing. If you want to figure out, have I actually done what I need to do for this unit, then you should make sure that you can do everything that it says within the AICE objectives. The objectives tend to be a little bit more general, like I can apply the synthetic division, or I can apply long division. Now, you should pause the video at this point, answer these few questions, and then come back and see how you actually did on those. Now, you can actually find the answers in your textbook, or you can just look here to see exactly how you did. And hopefully there was no problems there. Adding like terms is actually an Algebra 1 objective. Now, multiplication, similarly, you can obviously do FOIL, you can do binomial times binomial. You need to probably go as far as trinomial times trinomial. So I put a question there. There is some clues on the side there, which probably better to cover up for right now. But basically, you're going to multiply everything in the first set of parentheses by everything in the second set of parentheses. So you do 5x squared times 2x squared, 5x squared times positive 3x, 5x squared times negative 4. And then once you have done all that multiplication, you move on to the second term in the first set of parentheses. And then multiply each term by negative 4x. Once you've done that, move on to the negative 1 and do the same thing. Multiply every term in the second set of parentheses by negative 1. Notice there's 3 terms here and there's 3 terms here. 3 times 3 should give you 9, and then on the right hand side that would be what those 9 terms are. Now, as you're combining them, I would actually write them down in groups of 3. So start with that first 3 terms. Notice where I put the next 3 terms. I'm already lining terms up, so when I come to simplify this, it's going to be much easier to add terms together. So up here, it was kind of difficult, 15x cubed, and then I got to kind of look down my line here to see where my other terms are. If you line them up as you go along, it should make them a lot easier to do. And then just check that you're agreeing with these answers. Just make sure that you're not adding exponents here, because you only do that when you are multiplying. So you're just saying how many x cubes do you have. So positive 15 add negative 8 is positive 7. Similarly, you should spend a few minutes doing the 4 questions that you can see below. Pause the video and then come back and check to see how well you did. And those should be the 4 answers to those questions as well. Let's move on then to the main part of the lesson, which is going to be long division and synthetic division. Now, we're actually going to start off with the synthetic division. That's probably the easier one to do, but you do need to know that it only works for certain questions. It only works when you're dividing by linear expressions. So if you're dividing by anything except for that, then this method won't actually work. So for a question like this, 2x squared plus 6x plus 7 divided by x plus 1, we switch the question around because what we want to say is how many times does x plus 1 go into 2x squared plus 6x plus 7? Now, we use the factor theorem here, so if we know that x plus 1 is a factor, then we know that negative 1 is a root. So we do the opposite for whatever this term is as our number that we're going to use. Now, the reason synthetic division is easier, it doesn't involve any algebra terms. All you're looking at is the coefficients here. So 2x squared, I'm going to put 2, 6x, I'm going to put 6, and positive 7, I'm just going to write down 7. Now, when it comes to actually working out the steps, this is what we're going to do. So the first step is to bring down this first number, so the 2. You then multiply these 2 numbers together. So negative 1 times 2 is positive 2. Is negative 2. And you write that underneath the next column. Then you add these 2 things together. So 6 add negative 2 is positive 4. And then you just repeat the same process again. So 4 times negative 1 is negative 4. add these two terms together, and that will give you positive 3. Now, it's also important to know what this answer actually means. So we took away the algebraic terms here, so at the end we have to put them back again. So this number on the end is our remainder, 4 is just our constant term, and 2 would refer to 2x. If there was an additional term, it would be x squared, and then x cubed, and so on. So as you can see here, the answer is 2x plus 4 with a remainder of 3. But really all you're doing here is adding, subtracting, and multiplying numbers together. So although this is an AICE2 class, this is very procedural. So it's an important method to make sure you've learned. Let's take a look at a second example. It's not quite so easy when we have something that's not just x. On the previous one we had like x minus 1, you could just do 1. When it's 3x minus 1, what we're really doing is solving this. When does this equal 0? So we can find out what the root is. So if you solve this equation equal to 0, you would find the answer 1/3. Same as before, I'm just writing down coefficients here. Then I can start going through that procedure. So I bring down that first number. I then multiply these two numbers together, which would be 1. Then I add those numbers together in the next column. 5 add 1 is 6. And 1/3 times 6 is 2. And then when I add them together, I get 0. So using what I did before then, the remainder is 0. The constant term is 6. And that would be 3x. That seems to be correct though, right? However, that's wrong. If you multiply these two terms together, you should get this term, but you don't. You actually end up with something that's totally different. Notice, however, can you see that all these terms are actually 3 times too big? So what we actually have to do on the end of these questions is, if it has a fraction like this, whatever is the denominator, you need to divide your answer by that. So take each of these terms, each of these terms and divide it by 3. So the answer is not 3x plus 6, it's actually just x plus 2. The remainder you do not need to divide by 3, although it wouldn't change the answer for this question. So it's only the quotient part of the answer that you need to change. And that's often a question that people will forget when they haven't done synthetic division for a long time. Now, part of the assignment is to go ahead and try 5 questions. So you might want to start with these ones now, perhaps pause the video. Question 1, not quite so nice because you got to solve this equal to 0. You got negative 4/3. Not wonderful numbers, but your calculator has fraction buttons on if you're not so good with your fractions anyway. So you might want to pause at this point and try those 5 questions. All right, welcome back. The other method is long division. And the advantage of this is it works for any question. So you don't just have to divide by linear. You can divide by quadratics, by cubics, by anything you like. The disadvantage is it's a little bit more difficult. So normally I probably use 2 methods. If I'm dividing by a linear, I'm probably going to use synthetic division. If I'm not dividing by a linear, I will probably go to long division. And normally there's some people that will do long division for every question just so they only have to learn one method, and that'll be something that you can make a decision on for yourself. So first question, 2x squared plus 6x plus 7 divided by x plus 1. So I set the question up like a normal divide question. And then I ask myself, how many times does this first term go into the first term here? So in other words, what do you times x by to get 2x squared? Now, some people prefer to ask the questions 2x squared divided by x. So it's the same answer, but I think it's just a personal preference. So x times by 2x gives me 2x squared. If you haven't seen the video for long division with numbers and you've totally forgot that method, go check that out on the YouTube page as well, and then that will make this a lot easier while you're doing this. So we multiply back here. So 2x times by x is 2x squared, and 2x times by 1 is 2x. Notice it's subtract, and notice when we did synthetic it was actually addition, so that's sometimes one thing that people often mix up. You do need parentheses here to show you're subtracting both of these two terms. And then go ahead and actually do the subtraction. If the first terms do not cancel, then it means you've done something wrong anyway, and then you can go back and try and do the question again. Once you've got your answer of 4x, then just go ahead and bring down that next term. Then just repeat the same process over and over again. So what do you times x by to get 4x? And then multiply back. 4 times x, 4 times 1. Same as before, subtract, and make sure you have parentheses around that answer. Notice those first terms cancel again. and 7 take away 4 is 3. So the answer to the question then is the quotient is 2x plus 4, and the remainder is 3. And I believe that was the same question we actually did by synthetic, so you might be able to go back and check that as well. It's actually a good exam technique as well. If you have time on a question, try doing both methods. If you get the same answer twice, you can pretty much guarantee you've got it correct. If you have different answers, then you can go and look and see if you can find out where the mistake actually was. Now, I made this question a little bit longer. I made it into a cubic this time. So we'll set out the problem as we did previously, as in we'll reverse the question, like how many times does x plus 3 go into that polynomial? And x times what gives you x cubed? That would be x squared. Multiplying back, we get x cubed plus 3x squared. We're going to go ahead and subtract, and we're going to bring down that next term. X times by 5x gives me 5x squared, and then multiply that back as well. Subtract, and then bring down that last term again. And x times 4 gives me 4x, and multiplying back one more time, and I should end up with an answer or a remainder of 0. So my quotient is what you can see at the top of the question, the x squared plus 4x plus 4, and the remainder is 0. One other thing to mention at this point, and to watch out for carefully in questions, is if the question had only been x cubed plus 19x plus 12, you should definitely be putting a 0x squared here to show that there is no coefficients. There shouldn't be any gaps on the terms up here. So notice the powers go nicely, 3, 2, 1, although we don't write 1, and technically the constant term is 0 because there is no exponent at all for that one. So it's something to watch out for when you're doing questions as well. Now, why are we actually doing this? There is some applications that might be useful for us while we're doing this question. This is what we actually just worked out. But the question could ask you to do this as well, which is something you actually did in AICE 1, but not quite at this level because you weren't at that point then. So, as we've already fully factored for part A, let me write down what that actually is. If we know that this divided by x plus 3 is this answer, then if we multiply both sides by x plus 3, we can actually say what that original polynomial is. Notice this second polynomial actually factors. And once we've got to that, then we can actually start working out what the graph would actually look like. So once we know what the factors are, then clearly we also know what the roots are as well. So where it says positive 3 here, I know that that means negative 3 is one of my roots, or x-intercepts if you prefer. Same for positive 1, that means negative 1, and same for positive 4, which means negative 4. And then if you go ahead and graph those, you can actually come up with a pretty good sketch for what this actually looks like. Remember, this is positive x cubed, and that's one of your general shapes that you should know from Algebra 2, and also from AICE 1 as well. Okay, at this point, to practice those skills, you should work on questions 6 through 10. Now, the full assignment actually goes a little bit further. So you've done 5 on synthetic, 5 on long division. Make sure you've got the same answers for 1 and 6, 2 and 7, as they're the same questions. And if not, you obviously know something went wrong. And then 11 through 14 is more like the AICE questions. So notice for some of these, you're actually dividing by 3 terms. So when you multiply back, you'll have to multiply back 3 times. I've given a show that question. AICE often does that, so you can actually check your answer to make sure you've got it correct or not. So if you do find you've got r equals negative 3 for question 11, that means you know you have the right method and you can just move on to the next question. Question 14, I actually put in 2 different letters for this one, just to see also how they can start messing with you by adding in some additional algebraic problems to this. Question 13, just written slightly differently. So you'll have to think about what does this 2x minus 1 to the power of 4 actually mean as you're coming to answer that question. Probably the next lesson we'll talk about 11, 12, 13, and 14. I have the answers on the side here, and I'm sure some of those might possibly cause problems. Now, right at the end of the lesson, I always like to do this question, and it's very similar to one of the homework questions as well to kind of guide you through a bit. What is the remainder when this expression is divided by x minus 2? And we normally have a time challenge as well. See how long it takes you to answer this question. And most people go straight back into their AICE 1 knowledge. They remember the binomial theorem. They'll either draw out Pascal's triangle or they'll remember the NCR button on their calculator. They'll start simplifying this, basically so it looks more like a traditional polynomial. And then they can start answering this question. I'm doing this by synthetic, but you could do it by long division if you prefer. And, whoops. You would come up with this answer. And remember, this very last number down here is actually your remainder. This tells you what the quotient is. So this would be 0, 2x, negative 2x squared, 1x cubed. So x cubed minus 2x squared plus 2x with a remainder of 1. Now the question this time only says what is the remainder. So the answer would just be 1. Now that's all fine and that works absolutely perfectly. There is a shorter method if the question only asks you for the remainder though. So let me show you what that short method would be, and you can probably answer this question in about 5 seconds once you know what you're looking for. It'll take me a little bit longer because I'm going to explain it thoroughly. So here is my factor. So I'm going to use the root here, which is this number here. All I need to do is actually just plug this number into this expression and I can find out what the answer is. Now I'm not going to plug it into here because it would actually take a little bit longer, and I'm only looking at the top half of this fraction here. I'm going to go back to the original question. So 2 minus 1 is 1. 1 to the power of 4 is 1, and that's it. So a useful method to know, if the question only asks about remainder, you should just substitute in the number that you're given to find out what that remainder is. If the question, like the previous one, said fully factor, then I'm afraid there's no shortcut and you would have to do long division or synthetic division. That should do it for this video. Go practice. If you need additional help, the links are down below. Go find the YouTube page, and that will do it for this video.